Hello, everyone. Welcome to CIS277. I am Professor Bob Hendry, and today is your class and your lecture for the 5th of March, 2020. The 5th of March sounds a little bit strange because I can't believe it's already the 5th of March, and I can't believe it's still 2020. I was promised flying cars. Where are the flying cars? No flying cars. And March is a little bit strange, too, because we have baseball in March. If you're a Cubs fan, you'll know that opening day is the 30th of March, which is really coming along. That's going to be just in a few weeks. So we're right on the verge of spring. So welcome the class. Now, a few things. We're turning a corner here. We're going into their next scripting language. We've had two of them. Two-ish. Let me kind of explain. We had we were using Oracle Apex for our database scripting language, and then we went in the Java. Now, there's a reason why I went in the Java, as I kind of explained to you in the past, and certainly to a few of you offline as we're talking about this. Java isn't really a scripting language. It's more of a full-fledged citizen of the programming languages, but it's still important to learn it or to have some more in-depth experience using it, even when we're using scripting languages. And let me tell you why. But a lot of the languages that we use for scripting, such as Python, Groovy is a good one, and there's some other ones as well, are very Java-ish in the syntax. So learning Java is kind of like a prerequisite for doing this and for learning these other scripting languages. So don't look too far into it. But anyway, we're going to be learning one of those languages now, starting now. We're going to start with Python this week. We got about 3 weeks of Python, which is pretty exciting because Python's one of the newer languages for me. I've only been doing some Python programming professionally for about maybe a handful of years, which is not really a lot. It's a drop in the bucket if you consider that I've been writing code since the RPG and the COBOL days. I won't tell you when those are. For those young people out there that if you're under the age of 30, you could Google RPG and COBOL, and you could figure out basically when I started. So anyway, we're going to move onward and upward today. We're going to start with some Python programming. I have an introduction to Python, which is going to take about maybe 25 minutes or so, and then a little bit on Python functions. So it's going to be kind of starting Python from square one. And we're going to be using Coding Ground to do it. Have I ever told you how much I love Coding Ground? I love it because it allows us to just do a variety of just different languages without downloading a bunch of IDEs. It gets us up and going really quickly. So that is where we're at in class. I have your next assignment posted, which is a Python programming assignment. It's not going to be due until March 15th. So you still have well over a week to work on it. It's not too difficult. You should have your hands full. Most of you are still catching up. So anyway, watch my demo lecture, do your reading, and start digging into your assignment. And please reach out to me if you need to. Remember, we just don't meet in class anymore. This is the year 2020. So class kind of comes to you. So if you need my help, I do have availability. Like on Wednesdays, I'm on campus, late afternoons, early evenings. On Fridays, I am on campus, early afternoons and evenings. And most of you have found me online. We could do things via Skype. We could do things in a variety of different ways. Anyway, I'm kind of beating this into the ground here. You know where to find me. If you need me, please reach out. We'll get you all squared away. So in the meantime, I'm just going to take a little bit of a pause, and I'm going to pause the video a little bit. I'm going to go in the Coding Ground. Let me log in the Coding Ground and get Python ready to go. So you're going to get about 30 seconds of a silence, and we're going to start with Python. So let's get started. Now I have Coding Ground open here, and what I did is when I logged in the Coding Ground is I started a Python project. Now I'm using Python 3. There's other different compilers that we could use for Python, and there's also like a Python command line. Now, for our purposes, You could probably use any of the three. There are slight differences between like Python 2 and Python 3, so you may have some small little minor differences or some little tweaks you might have to make to the code to get something to work in Python 3 that won't work in Python 2. But anyway, I digress. I'm going to try to stay as neutral as possible. So all I have here is I have a print statement, print hello world. So I'm going to click on execute, and if you look at the results on the right, you successfully see hello world. If not, change your program just so you match what the output is. What we're going to do here is our objective is to kind of add to this program a little bit, and by the end of this demo, you should be able to have a good understanding of how to at least write a simple Python program from scratch. So we're going to get more complicated as we go. Although this code example is not going to be terribly complicated, if you have more than really just a few weeks of experience with Python, this might be a little boring. This is intended to be a kind of a first shallow dive into Python. So let's start now with adding a variable. I declared a variable called name. Now notice when you declare a variable in Python, you don't have to specify the data type. A little bit more about casting later. Casting, again, is if you take one data type and make it into the next. It works just like that on Python, but there are some other things you need to do. So what I did here is on line 3 is I have a variable named Bob, and then on line 4, well now that's line 6, I'm just doing a print hello, and then you see Bob, for the name. And you saw when I clicked on execute, you see on the right hand side the hello Bob. So let me add a couple more variables here. So we got name equal Bob. Now notice Bob is a string. We have weight equals 135.5. Hey, it could happen. That is a floating point or a real number. And we have age equals 39. Now that's an integer. An integer is a whole number. We talked a little bit about strings, whole numbers, and real numbers. So you see one of each here. So I'm going to add a couple more print statements to show you that when we print things out or variables out, such as name, weight, and age, we don't necessarily have to worry about their data types. We don't have to cast them from a number into a string. Python will do that for us. So if we're printing something out, everything's kind of a string, we don't have to worry about it. That's going to change a little bit when we do some math with this. So really quickly, on line 7, 8, 9, I'm going to say hello, name, your weight, or you weigh, and then my weight, and then your age is an age. So when I run this program, I should predictively get, hello, Bob, you weigh 135.5, right? Yeah, hey, it could happen, and your age is 39. So we did a couple things here. Let me click execute, make sure it works. Look on the right-hand side, and we'll wait for it, and it looks like it works just as advertised. Not a big surprise there. So what we have here is we got a simple Python program that has 3 variables of 3 different data types. We have a string, a float, which is a real number, and an integer. An integer is 39. Remember, integers are whole numbers. And when we print them out, the string is no problem, and then the weight and the age are no problem as well. But behind the scenes, what's happening is Python is casting all of these variables into a string. So weight, name, and age are all strings. Let me change this up a little bit, and let me get rid of the hard-coded values and get the values from standard in, which is from the command line if you're doing this, from a REPL or doing this from a command prompt. Here you're going to see it under standard in, but I'm going to use the input statement to get these values as input into the program, which makes more sense if you think about it, because before what we did is we just had these values hard-coded, which doesn't allow them to be very, what's the word I'm looking for, flexible. So we have name, weight, and age. I'm just going to change the text accordingly. And then what I'm going to do is eventually, once I get this to compile, it looks like it's good, is I'm going to supply the name, the weight, and the age from standard in here. And like I said, if you weren't using Coding Ground, if you were using a command prompt, you would be prompted for this, or the user would be prompted for it. Let you get a good look at this, and when ready, what we're going to do is we're going to go to standard in, and we're going to supply the name, the weight, and the age. So I'll put in Bob, and then the next one is I'll put in my weight. I'll put in 159.5 pounds. We're getting a little bit more realistic here. And then for the age, I'll put my age in as well. So our inputs have to match the number of inputs that we have in our program. So we're asking for 3 values: the name, the weight, and the age, and we're supplying them here in standard in. And again, for the 50th time, if we were writing this from a command prompt, you would see these values being prompted and the user would actually type them in. So we're almost done. So if I don't have any syntax errors, it should run, and you should see on the right hand side, please enter your name, please enter your weight, please enter your age. And you're not going to see necessarily right away the input, but you will see them with the print statements on lines 7, 8, and 9. So when you're ready, you click on execute, and if things work, you're going to see it on the right. Hello, Bob. You weigh 150.5 and your age is 39. And then you see the prompts that I have highlighted here. Now, if you don't get this, you could obviously just pause the video here. Again, this is a short demo, but it's kind of condensed. So I kind of really fully expect you guys to kind of pause this, as I'm going through it and actually try it till it works. So, I mean, there might be only, a half an hour of demo time here, but as you run through it and stop it and fix your errors, it'll probably take longer, maybe 90 minutes an hour, an hour and a half, maybe a little bit longer. So now let's do a couple more things. All right, so what do we have so far? We have 3 variables. We're inputting those variables from standard in, and then we're printing them out. So let's start doing some math now. Now this is where not everything's going to be a string, because right now name, weight, and age they're strings because we're not saying they're anything else. And that's kind of what's a little bit different with Python. That's slightly different than other languages, where other languages in most cases you specify what their type is, and Python not really. If you don't say anything, it's kind of a string until you say otherwise. So if I do math here, I'm going to force my weight to actually be a number. In this case, since I'm going to take the weight times 0.90, its best weight is actually going to be a floating point. Floating point just means that it's got a decimal on it. We also call those real numbers. So you'll hear me say float or real. They mean the same thing for the purpose of this demo. So best weight here is going to be different because I have it equals to the weight times 0.90. So if I try to run this, I should get something a little bit strange. See how I get an error in here? Can't multiply sequence by a non-int of type float. What that means in English, if you're familiar with other languages, is I got a casting problem. The data types don't match. Best weight equals weight times 0.90 doesn't make sense. All right, so why doesn't it make sense? Because best weight doesn't know what variable type to be, because on the right hand side of the equals operator, on the right hand side of the expression, we say doesn't have matching data types. So weight here on line 8 is really a string, and we're trying to multiply it by 0.90, which doesn't make any sense. So what we have to do, there's a few things we can do, but first and foremost, we're going to make weight a floating point, because now weight on line 8 times 0.90 is a floating point times a floating point. So when that gets evaluated and gets put into the left-hand side of the expression on line 8, on the left-hand side of the equal sign, we have a float. So best weight will be a float, weight will be a float, and 0.90 is a float. So when we execute, we're not going to get an error. You're not going to see anything different because we didn't, print anything out. We're going to change that now. So on line 12, let's say print, and we'll put something like what your best weight is so we can just see it. It'll work. I mean, we don't get the error message because we fixed the problem on line 8, or at least manifested itself on line 8. So we're going to change, or not change, we're going to put in line 12, your best weight is best weight. Now Python will cast line 12, best weight, into a string and print it out for us. So we got the best weight is 143 point something. It's a little small, I can't see it. So anyway, if you know how casting works, you can look at Python and study how it casts from different data types. If you don't know what casting is, you have a little bit of an assignment. Casting is basically, again, making one data type into a next. So if you don't know what casting is, that really is the topic for a different video. But hopefully here we're giving you some rudimentary examples of what happens when you try to do arithmetic with different data types. So anyway, let's continue. So on line 10, I'm going to put in something like my best age is 75% of my current age. So we all want to be lighter and we all want to be younger, right? Well, at least when you're my age. And when you're smaller or younger, you probably want to be bigger and you want to be older. But believe me, that goes away pretty quickly. So on line 11, I'm going to put in best age equals age times, and I'll put in 75. So we'll get my optimal age, right? I won't say what it is, but I remember the 70s. The 70s were cool. If you missed the 70s, obviously all of you did. You really missed a really good decade. We had a lot of fun. Okay, so let me execute, and you're going to get that error message, can't multiply sequence by a float. So what do? Let's take age on line 5 and change the input and cast it into a float. So I'll give you an imaginary extra credit bonus point if you got that correct. So let's go to age and change that to a float. Oh, in this case, no, I take that back. Let's make it we can make it an integer. So on line 11, we got age as an integer. It's being multiplied by a float, which is 0.75. So that cast, in this case, will work. So we can do arithmetic in Python, like on line 11, with integers and floats without casting them. As long as it's numeric, we're fine. And then best age on line 11 will cast into a float. And then when we print it out, it will cast into a string. Now, if all this sounds like ancient Greek to you, like I said, you probably need to brush up or learn about casting. And casting's a big deal. It really is, because each language casts a little bit different. So it's something you need to learn anyway. If you already know the concept of casting, you kind of know where to go from here. So anyway, on line 17, I put the line of code in there. Your best age is best age. So best age will be cast into a string, and then it'll print out as you see here in the results. The last line, your best age, or you best age, spelled it wrong, is 29.25. Sounds like a good age. I don't think I remember that far. I'd have to go farther and go all the way back around. I'm closer to going all the way to the end and starting at 0 again. All right, so we did a lot here. We did things such as declare variables. We did some arithmetic. And then what we did is we just printed them out. So and while we did it, is we kind of did some casting. So we're going over a lot here, believe it or not. This is quite a bit for your first Python program. It kind of is. So now, since we're already doing a whole bunch of stuff here, let's play our winning hand into a flow of control statements. I'm not going to go into all of them, but I'll go into a simple if statement. Now, all of you have had some language before. I'm hoping you did. So I'm not going to go over what the branching statement is. I think I called it something else before, but yeah, if's a branching statement. So if something is true, do this, else do something else. So if you need to know more on Python if statements, Google is your friend. You'll find out all you need to know here. But I'll just show you some simple syntax. So here I got if age is less than 0, print your age must be greater than 0. And we'll do something else. We'll do how about this? Your age has to be between 0 and 100. So there's your if statement. Notice we got a colon after the expression. So then we're going to put in exit. Exit means that we're going to stop the execution of the program. Again, look this up because there's a lot that has to do with exception handling with stopping here. Right now, exit will just terminate the program, but there's a lot more going on behind the scenes. So take some time to learn about exit. And then let me put in an else if, which is actually an elif. We'll put in this age is greater than 100. We'll print something like the age must be or cannot be greater than 100. I don't know why not, but hey, it's our program. We could do whatever we want, right? So we have age cannot be greater than 100, and then we're going to not do an end if. We're just going to do another exit. No, we don't do end ifs. Notice there's a few things here that are noteworthy. Ignore that, sorry. Number one, we don't use braces, and we don't have like end ifs here. This is based on tabs, not on bracketing. So that's going to be something you're going to have to get used to, is the syntax for Python doesn't have the brackets or the braces in them. So we don't really do with blocks as much as we do with tabs. Because right now you're looking at this, you're like, well, where does the end if end? Well, it end, the number 11, line 11 ends at line 13. So anyway, when we execute it, getting a little ahead of myself, we should get, nothing here. What we need to do is we need to change our standard in to trigger one of these if statements. So let me go into standard in eventually and try to break it. Well, not break it, but just test it. We'll put in an age less than 0 and an age greater than 100, and we'll test it to see how it works. But it should work accordingly, where, if it's less than 0, we're going to get the age must be greater than 0. 100, we're going to get the same. But let's try one. So let's change my age to something a little bit big, like 102. And then let me execute my program. And on the right-hand side, after I execute, you're going to get age cannot be greater than 100. And notice, we don't get the print lines or the prints on line 21 through 25. And the reason is because we hit that exit on line 10. So it terminates the program right there on line 10 and exit. So if you want to, you could go to standard in. You could test the other end if, or pardon me, the else by putting in, a negative number or not. It'll work as advertised. So anyway, that is a simple branching statement. There are different statements such as the fors and the whiles, and there are flow of control statements. So if you want to know more about them, again, Google is your friend. I'm just trying to get you a quick Python program under your belt. Again, this video and this demo that I'm doing right now, this lecture, are for those of you that have not necessarily written a Python program before. If you have, you're probably in the wrong spot. But yeah, this is just coding ground for Python. Now, there's other things that we can do with this. Like, for example, if you wanted to do something like make some of this into a function, you certainly can. Notice what we did here is we have, quite simply, what we have here is we have the a program without any methods in it. So basically what we're doing is we're just writing a top-down program, but it doesn't have any methods in it. Like Java has main and it has methods. This one doesn't. So what we're going to do here is we're going to add a method to our Python program. Now, there's various ways we could do this. Generally, how about this? What we're going to do is we're going to create a method at the very top. Generally, you're going to create a function, at the start of your program. So basically, you're going to start with functions, and then from there, you're going to call them. Now, there's different philosophies on this, and there are different ways to do this, but, my famous saying, it's my program, I can do whatever I want to. So again, the purpose of what I'm trying to do here is trying to get you, a quick and easy example to work from, and then you could rip it apart and tell me everything I did wrong later once you get it working. If you don't get your program working, I don't want to hear how I did it wrong. Makes sense, right? Once you get it working, say, you know what, Bob, there are other ways to do this, and we'll certainly have a conversation on that. So on line 4, I'm just going to quickly do a define a function. So I define a function, and my function, and notice how I got the colon at the end of my function, and all it's going to do is say hello for my function. Notice I don't have anything that ends my function. Looks unsettling, doesn't it? Because we're working in a tab-based environment. There's no brace, there's no bracket, there's no end, there's no anything. Now what do I do? Well, you'll get used to it, trust me. So anyway, that's defining my function. So I have a function called my function print hello from my function. Now, this function isn't called from anything. It's just hanging out there, right? So after you define your function, what you need to do is you need to call it. So I'm just going to put some code in there to do that. So don't try to connect a lot, all the stuff I was doing before into that. So rather than clearing the screen and doing all this stuff from scratch again, we're just going to kind of, make this messy and just call the function from here just to show you how you can call it. Generally, you call the function after you define it, or you might have some error messages or some problems. So we defined it on line 4 and 5, and I'm calling it on line 22. So when I run, you're going to see, let's see, hold on. Let me put in my function. I got to change my syntax a little bit. Yeah, I'm not taking any parameters into it, so I need to put that an open and close with no parameters in there. So I get hello from my function. And I'm also going to get all my other hellos all the way down, because I'm calling, I'm firing off my logic, then I'm calling my function. So I'm not saying this makes a whole lot of logical sense, so don't look into it too much, except that I'm calling my function on line 22. My function is defined before line 22 on line 4 and 5. That's all you need to know for now. So we have a function, right? We're calling it here on line 22, and it's being defined on line 4 and 5. So we're not passing anything into the function, right? Let's change that. Let's add some stuff to the function, or add some stuff that we're going to send into the function. So let's just say we're going to pass into the function the name. So I change line 22. I'm going to pass the name into the function. And on line 4, I'm going to do the same, name. Notice I don't do anything such as input, output, and I don't even say the data type. All right? Easy peasy for now. Remember, this is Happy Path. So I have really, just let's see, hold on. Let me just review. I got my name, I got my weight, I got my age. Looks good. We're even, Steven. We're ready to go. I should be able to run this. Let me look at the execute tab. I keep calling it a button. It really isn't. So I click on execute, and then you should see the results on the right-hand side. You're going to see hello Bob twice, right? You see hello Bob the first time from the results from line 5 and also from line 27. And again, I hope you're pausing this big stream of consciousness that I'm giving you right now, and you're getting your examples to work, and you're kind of looking over it. Again, this is the condensed version. I fully expect that, as you go through this, it's going to take 3 times, maybe 4 times the time, because you're going to be stopping and starting. So anyway, we got line 4, 5, and 6. We're defining a function, right, called my function. We're passing in the name. On line 22, we're calling the function, giving it the name, and all it does is it just prints out hello name. So we got a whole bunch of other stuff here. So we got in addition to that, we got all the stuff that we did for the first example. So a lot of this is kind of, I wouldn't say dead code, but doesn't necessarily have to do with calling the function, but you guys get it. So what do we do now? Well, what we can do now is we can change our function to create to accept different arguments. For example, if we wanted to pass in the name, the weight, and the age, we could. So we'd have to do that on line 4, where we're defining the function, and we'd also have to do it on line 22, where we're calling it. So let's do that. So on line 4, I'm going to change the function to take in the name and the age. And then on line 22, I'm going to just add age, passing it into the function, and then I'm going to change the functionality of this extremely useful function to say your age is, and put in age. Notice how a lot of this casting kind of happens for us. Strings become numbers, numbers become strings, and a lot of that happens behind the scenes with us. And we don't have to necessarily have to worry about it, but sometimes you do. Like you saw on line 9 and 10, we had to specify the floats and the integer. So when you do math, casting becomes important. Let me just comment out some of these prints here, just so you could see the hello Bob, your age is 39. I think that's 39. That print is really small. So anyway, what we did here is we defined our function. So in this example, you wrote a Python program. You learned how to declare variables, how to get input from standard in. You learned a little bit about casting. You learned a little bit about branching with if statements. And you created your own functions. So that was a whole lot in this short video. So hopefully this will get you on the right path with your Python programming, and you're going to get more complicated from here. Thank you for listening.